Hi, I'm Luca. Welcome to a new research paper summary by marktechpost.com. Today we are gonna talk about an explainable AI method developed at the Duke University. The purpose of explainable AI methods is to help humans to understand and interpret the predictions of a machine learning model. The major challenge is to explain the predictions of black box models due to their opacity. For example, deep learning methods are considered as black boxes since they are highly recursive and too complicated to be understood by humans. Today, we are gonna focus on image classification tasks faced by using deep learning solutions. The solution proposed by this paper is based on the following intuition. As you can see in the figure, when we describe how we classify the image of an animal, we might focus on parts of the animal and compare them with prototypical parts of images of the same animal. The goal of this paper is to introduce a neural network called ProtoPNet, which is able to identify several parts of an input image that look like prototypical parts of the classes present in the training data. Hence, the predictions of this network will be based on the similarity scores between parts of the input image and the learned prototypes. In this way, the developed model is more explainable and interpretable than a standard deep neural network, since the reasoning process behind each prediction is transparent. Now, let us consider the application of the ProtoPNet for the image classification of bird species. Given an input image, the convolutional layers of the network extract useful features from it. Then, the network learns a certain number of prototypes, where each prototype can be considered as the latent representation of a prototypical part of the bird input image. The researchers allocate 10 prototypes for each bird class of the dataset, so that every class will be represented by more prototypes in the final model. Given a convolutional output, the ith component of the prototype layer computes the distances between the ith prototype and all the patches of the convolutional output that have the same shape as the considered prototype. The distances are then inverted to obtain similarity scores. The result is an activation map of similarity scores. This activation map can be upsampled to the size of the input image to produce a heatmap that identifies which part of the input image is most similar to the learned prototype. The activation map of similarity scores produced by each prototype component is then reduced using global max pooling to a single similarity score. This can be understood as how strongly a prototypical patch is present in a part of the input image. Finally, the similarity scores produced by the components of the prototype layer are multiplied by the weights of the neurons of the fully connected layer. The softmax activation function is used to obtain the predicted probabilities for the input image belonging to the dataset classes. Let's focus on the figure. The similarity score between the first prototype, a clay-colored sparrow head, and the most activated patch of the input image for this prototype is equal to 3.9. On the other hand, the similarity score between the second prototype, a brewer's sparrow head, and the corresponding most activated patch in the input image is 1.4. This means that ProtoPNet finds that the head of a clay-colored sparrow has a stronger presence than the head of a brewer's sparrow in the input image. Indeed, this will increase the probability related to the class clay-colored sparrow in the final prediction. Now we will focus on three aspects of the optimization process used to train the ProtoPNet. First of all, during the training process, the cross-entropy loss is used to penalize misclassification on the training data. Then, a cluster cost is minimized to encourage each training image to have a latent patch that is close to at least one prototype of its own class. Finally, a separation cost is minimized to force every latent patch of a training image to stay away from the prototypes of the other classes. Did you like this explainable AI method? If yes, leave a like on this video. I hope to see you again in the next research paper summary by macteppost.com.